All right, in assignment number 4, we're going to do compounded interest like we did before, but not compounded annually. Sometimes we're going to compound it semi-annually or monthly or quarterly. We're going to figure out what that is about and how to do those kind of questions. And we're going to talk about compounded continuous interest. So we're going to learn what those are, and let's go ahead and get started. So here's the situation. Suppose you invest $4,000 in an account that makes 12% interest for 8 years. So we know that we're going to be in a general equation that looks like this: y equals a times b to the x. And so our a is our beginning amount, which is $4,000. So we're going to have 4,000. We're going to multiply it times 1.12, because if you're making 12% interest, that means that it's 12% more than 100%. If it was just 100%, you'd stay the same. So it's times 1.12 to the 8th power. And it's to the 8th power because it's for 8 years. So if you invest $4,000 at 12% interest for 8 years, you're going to make $9,903.85. So if we were to graph that, we'd be about right here. And the 1 down here represents that it's compounded 1 time per year. However, let's say you go to a different bank, a competitor, and the different bank says, well, we're going to compound your interest semi-annually. What that means is they're going to give you half the interest, half the year, or halfway through the year, and then that's 6% halfway through the year in 6 months. And then the other 6 months, the other 6% interest, the other 6 months. And so what you'll have is something that looks like this. You'll still have a beginning value of $4,000, but then they're going to give you 6% interest. So we're going to multiply by 1.06 after 6 months, and then another 6% they're going to give you at the end of 12 months. So over a period of 8 years, they're not going to compound your interest 8 times. They're going to compound it a total of 12 times, or a total of 16 times, because it is 2 times every year. And so if you take $4,000 times 1.06 to the 16th power, you're going to get $10,161. So 10,000. This equals $10,161.14. So that gives you a little bit more money. Now, it's not a lot. It's maybe a little less than $200 over that 8-year period. But if you're compounding it twice a month or twice a year, that means the money that you made at the first half of the year, that's going to make you money the second half of the year, and that makes a little bit of a difference. You're going to make a little bit more money. So here's $10,161.14. So you make that much more money. So that's a good thing. So you go to a different competitor, a different bank, and they're like, well, if they're going to compound the money semi-annually, we're going to do it quarterly. Well, that means every 4 times a year, they're going to give you 1/4 of the 12%. So we're going to start off the same way. We're going to have the $4,000 at the beginning. We're going to multiply it by not 12% or 6%, but 1/4 of 12%, which is 3%, so 1.03. And over a period of 8 years, compounding it 4 times a year, they're going to compound it 32 times. And that gives you $10,300.33. So if we graph that, it's a little bit more. Now, not much more. If we compound it 4 times a year, we're down here. It gives you a little bit more money. So you go to another competitor, and the other competitor says, we're just going to compound it monthly. And so if we compound it monthly, it's going to look something like this. We're going to start again with $4,000. If you compound it monthly, that means you're going to get 1% every month. So you're going to multiply it times 1.01. There are 12 times a month for 8 months. So that's going to be to the 96th power, because 12 times 8 is 96. And if you calculate this, that means at the end of 8 years, you're going to have $10,397. $97.09. And so at the end of 12 months, we're right here. So you can kind of tell we're kind of leveling out here as far as how much money this can make it. But let's go a few more here. Let's say that we go daily. So if we go daily, again, we're going to have $4,000 at the beginning. We're going to have to multiply by an interest rate where we're going to take 12% divided by 365. So that's going to be 1.0000325. That's a 3 there. And then we're going to have to raise that to a power where we're going to take 365 days a year. We're going to have to multiply it times 8 years, which is to the 2,900. I don't know why it's not working here. 920th power. And we're going to see how much money this is going to give us. Okay, I think I forgot an extra 0 in here. It's there's 4 zeros, 0.0000325 to the 2,920th power. That's going to give us $4,398.19. And so if we graph that, we're not going to be too much bigger, and it's off our screen. I don't have 365 going in this direction. Hourly would be even closer. It's not going up that much. You can see it only went up about $1 if I compound it daily as opposed to monthly. Compounded hourly is going to be the same thing. It's not going to be that much of a difference. It's actually going to reach a limit here. The top of this is going to look like this, where I start here about $9,900, and if I compound it continuously, like every second of every day, it's going to reach a cap here. Now that's called a limit. And so that limit can be found with a special formula. And we're going to talk about 2 different formulas here. The first one is the compounded interest formula. That's a formula that we actually have been using that looks something like this. It's where you instead of a times b to the x, the a is designated with a p. That's your principal. So in our case, it was $4,000. We're going to multiply it always by 1 plus whatever the rate is divided by the number of times you're compounding it. Like, for example, we had an interest rate of 12%, which was 0.12, but we divided it by, let's say if we compounded it quarterly, 4 times. And so that's how we got an interest rate of 1.03. And then the exponent is the number of times you're compounding it times the time. So in this particular case, if we're compounding it quarterly or 4 times a year, we're going to take 4 times 8, which is to the 32nd power. So that formula we have been using. What do all those variables mean? The P is the principal amount. The R is the rate as a decimal. So if it's 12%, it's 0.12. The N is the number of times you compound it in a year. So in our example here, it was 4. And the T is the number of years. So that gives you the compounded interest rate formula, unless it's compounded continuously. Compounded continuously is given by this formula, where P is still the principal, E is a special number like pi, and that is on your calculator. You can find the E on your calculator, and it's located on the 3rd row from the bottom, in a little e to the x button, right next to a button that looks like an ln. And if you go e to the first, it's 2.7. But the way this formula works, in our example, where we would have $4,000, it would look like this. We would take $4,000 as our principal. We would multiply it times that number e, and the r times the t. The r is the rate as a decimal, which is 0.12, in our example, times the time, which in this case is 8 years. And so if we take our calculators and evaluate what this expression is equal to, we're going to get a maximum amount of $10,446.78. Now that means if the bank just compounds it continually, every second, every fraction of a second, it's just continually being compounded. And so whenever it says compounded continuously, this is the compounded continuous formula. And so this is the formula that we're going to be starting to use whenever it says that our interest is going to be compounded continuously. Let's go ahead and see what this looks like in two specific examples. I would try this on your own. Shut the computer off. Try this on your own, and then start your computer and see, or start the video and see if this is what you get. How much money would you have in an account that makes 8% compounded quarterly if you invest $800 6 years ago? So here's our formula. We're going to have the principal is $800. We're going to multiply this times 1 plus our interest rate, which is 0.08, divided by 4 because it's compounded quarterly. And we're going to take our interest rate, which is our number of times it's compounded, which is 4, times 6 years. And so it is going to be 800 times 1, and then 0.08 divided by 4 is 0.02 to the 24th power. And so if I evaluate this on my calculator, we will get $1,286.75 if we round it up. That's if it's compounded quarterly. Let's take a look at another situation. Again, pause the video and then try this on your own and see if you get what I get here. How much money would you get? Would you have an account that makes 9% compounded continuously? So that's a big word here. Compounded continuously, which means we're going to use a different formula, if you invested $1,000 8 years ago. So in this case, we're going to have the principal amount is $1,000. We're going to multiply it times E to the 0.09 times 8. And so I'm going to stick that in my calculator, and that means 8 years later we're going to have $2,054.43. And so that's how we use these two formulas. That's what our homework assignment is going to be on. And if you have questions, we'll go over them tomorrow in class.